Hi, I'm Joe Justice. I'm from a little farming town in Indiana, and I got really lucky. I got to work directly with Bill Gates. That was absolutely just a lucky break. And I learned a lot, as everyone who was working with Bill at that time, I think, did. And that experience was enough that it let me then consult to Amazon when Jeff Bezos was running Amazon. And I got to consult to Tesla as early as 2010. And I remember being shown a frame of a car. It was called Project White Star. And the frame, the chassis of the car, had two parts. It had what looked like a Mercedes-Benz S-Class, a big sedan, a big four-door car. And then it had a different part on the bottom that plugged in and plugged out. It was a battery pack. This was in 2010. And that's what became the Tesla Model S. Project White Star became the Tesla Model S. And that's the first time I got to consult to Tesla. And what I recommended was, can we cut it into more pieces that can be designed and built at the same time? And that launched, well, what I'd like to talk to us about tonight. Since then, I did become a full-time employee of Tesla in 2020, and that's part of the story that I'll try to share with you tonight. Some of you might enjoy that. And then I've gotten to work with Mercedes-Benz, who I work with now. Some of you were connected on social media, and you can see Mercedes-Benz posts pictures of me. Thank you so much, Mercedes. At different, well, thank you. At different events and summits and decision-making sessions that they run. And Toyota. Miho, my wife and business partner. Miho, where are you, Miho? Hello, Miho. Thank you, Miho. We live in Japan because Toyota has created so much business for us that we can base there full time, working with Toyota and their supply chain, Denso, etc., the families of companies. Now, Lean and the Toyota production system is famous all around the world, especially in Europe. And a Lean consultant, a true expert, challenged Miho and I, why does Toyota want what Tesla is doing? They already have the Toyota production system. They are where Lean came from. They are just in time. And Miho said they want speed. And this Lean consultant said, I don't believe you. They already have Lean. So the next time Miho and I were in Toyota City in Nagoya in Japan, Miho asked in Japanese the Toyota executives, why do you want to work like Tesla? And they said, speed, we're too slow. That was from Toyota. With that, I'll zoom in on a story, maybe. Maybe it's secret. How are the Musk companies so quick? I was teaching Agile project management and Agile hardware. I'd founded a company called WikiSpeed. Some of you might even know that story, making cars with Agile methods. And I'd been consulting to Tesla, and then COVID happened. And my in-person Agile project management training business went to zero. COVID shut down in-person training, especially in the beginning. And for me, I was out of work. And I wasn't sure what to do. I had a lot of respect for Tesla. They were really quick. And by what I could tell as a consultant, they were amazing. So I applied, like any person on the outside. I applied to be a full-time employee. And I realized there were 1,000 job applicants for every open position at Tesla. So I applied at SpaceX, and there were 1,000 job applicants for every open position at SpaceX. Apparently, Tesla and SpaceX are the #1 and #2 chosen place to work by graduating engineers worldwide. Somehow, I got in. I got the job. And I'm incredibly proud of this one. I was actually told I was Tesla's best interview. That that is a moment I will probably take as proud to my grave. Wow. So maybe more useful to this group is, well, what would make a good interview, right? They said because I'd actually done the steps that I would need to do in the company. And in a company like Tesla, you don't do just one thing. Well, I had run a little car company, Wikispeed, and so I had done composites work where you mix glue and orient carbon fiber fibers and try to squish the epoxy, the glue in, and then you measure for bubbles. But I'd also done metal work, and I'd negotiated with suppliers, and I'd taken cars through road legal testing. They said, you're the first person we've ever talked to who's done every step of designing, building, and testing a car. You're our best interview. Like, well, that's awesome. But that's what it is. That's the recipe for a Musk company is, have you done it? And what they want is as much of it as possible. So if you wanted a job at SpaceX, I was not a SpaceX employee. I visited SpaceX. If you want a job as a SpaceX employee, you'd want to build as much of a rocket as you can, like even small ones, you know. I mean, they want that more than anything else. They don't want someone who worked in Ariane Group or Airbus Military, because that person has made PowerPoints about building rockets. Or they built a small piece, right? So they'd want someone better who even has built little hobby rockets, but actually launched them, learned from them, and then built a better one. That would be a better interview. So how do these companies innovate? Some context, Tesla is the fastest growing company in the world right now. Depending on how we measure software licenses, Tesla is the fastest growing company of any type, depending on how we measure software licenses. Otherwise, we can at least say Tesla is the fastest growing hardware company ever. Tesla has 2.5 times as much cash as Toyota right now. When Miho and I are working in Toyota, they are really excited to do this. I'm lucky in that I've gotten to work with Lockheed Martin and the United Launch Alliance and Airbus and Boeing Military, most of the world's major aerospace companies. And they really want whatever this is. And I'll try to share it with you as concisely as I can in a small amount of time. The best-selling car in the world right now is the Tesla Model Y. That replaced the Toyota Camry that had been the best-selling car in the world for more than 20 years. So whatever this process is, it has some results. And that doesn't mean everyone here would want to work this way. But I think you'll enjoy learning how this works, and you could consider it. Elon Musk retweeted an earlier version of this presentation. I teach a class now on how Elon Musk runs companies. It's all online. It's 8 hours long, split over 4 days. Elon has open sourced most of Tesla's patents, not all of them, but most of them, saying it doesn't matter who makes all the electric cars. It doesn't have to be Tesla, but we need a lot more electric cars. And I really think that's how Elon feels. We cheered when Volkswagen sold electric cars. We cheered when Mercedes-Benz sold electric cars as a Tesla employee. I've never been in a company where we cheered for what might have been your competitors before. So this is why I get to share Tesla's practices. It seems the Musk companies want the rest of the world to speed up their innovation. When Elon retweeted my summary of how the Musk companies operate, Elon amplified one of the points. Everyone eats the same food, uses the same restrooms, etc. No executive chef or other ivory tower stuff. There shouldn't be this workers versus management two-class system. Everyone is a worker. Elon does not own a house. Elon sleeps in a sleeping bag in the factories. Elon works in the factories, drilling metal, unloading trucks. That made it really easy for me to feel that I wasn't being taken advantage of. If I worked really hard, it didn't just mean someone else got a bigger dividend. If I worked really hard, it didn't just mean someone else got another boat. Elon doesn't even have a boat. So it was really intense working for Tesla, but I think it was more sustainable and more fun because I didn't see anyone benefiting any more than I was, right? It felt fair. The first piece of what seems to make this whole method work so quickly is the cars are split into pieces. All the work is split into pieces that can be designed and built at the same time. That's pretty agile for the agilists in the room. The idea of agile is split something into pieces and have frequent deliveries of those pieces. Well, it's exactly the same at Tesla. The car is cut into pieces and each one is designed and built at the same time. That means we can do mob, group work, and explicitly assisted by AI, so I'll call it mob AI. We can do group work on these modules at the same time, designing, building, and testing them. And Tesla publishes that's 44% more people in a factory and 30% improved space and time efficiency. Now, the Musk companies famously publish low numbers. The actual efficiency gains are far higher than this. That means we don't have to work in traditional manufacturing lines anymore. We don't have to work like Toyota wanted to work in 1960 anymore. We don't have to use single one-piece continuous flow anymore, which is really expensive to change. If you have traditional manufacturing and you introduce a change, you have to reevaluate upstream and downstream of that change. It makes you not want to change. Instead, we can have extreme manufacturing, agile assembly. There is no line in Tesla or SpaceX. There's no linear flow at all. That'd be too slow to change. Instead, we have what are called agile cells. Each agile cell designs and builds one module, and they're all operating at the same time. Then there's robotic integration to put them together. DevOps. For those of us with an agile software interest, DevOps, automated integration, automated testing. So you have simultaneous development and assembly of the modules, and we can have an agile way of assembling a vehicle. And I know what some of you might be saying. If that's so good, then why doesn't Toyota do it? Some of you saw 49 days ago, Toyota has now unveiled their next generation vehicle architecture and its modules. It's what Miho and I have been recommending in Toyota City for a few years. It's finally here. It's 3 pieces. And the advantage of these 3 pieces is Toyota says they can change the center of the car at any time and they don't have to make any changes to the front or rear of the car. This allows parallel development and innovation. They can essentially run Toyota like 3 companies, the front of the car company, the middle of the car company, the rear of the car company, and they don't have any dependency on each other anymore. They can release updates as fast as they can in any order at any speed. Toyota says that will half development cost and that will half the manufacturing investment. And I think they're right. Now, 3 pieces of a car, those are still really big chunks. They're so big that those are still big waterfall projects with central planning and budgeting. This is not the agile that most of us would want yet. It still gets the CEO really excited. This is the previous CEO of Toyota when Miho and I were first engaging in Toyota City. This is Akio Toyoda. Akio Toyoda, quote, "We have to smash the Toyota way. I felt strongly that when I went to the field and looked at the products, I could see that the important thing was to put energy into the change points, to speed change, to increase the speed of change. These are the words of Akio Toyoda. At the time he said it, the CEO of Toyota Motor Company. Akio put his son, the future CEO of Toyota, into a series of classes with me. And the goal is to have Daisuke Toyoda, Akio's son, transition Toyota then to be an agile company. In many ways, I was simply lucky. In 2006, I published something that is now, it's one of the 3 things named after me now. It's Justice's Law. The number of the modules determine how many business units you have in your company. The optimum company structure for pace of innovation is where for each work stream, parallel executable work stream or module, that's a business unit. So Toyota, with their next vehicle architecture, can have three business units, each with their own budgeting, their own procurement, their own testing, so they don't have to wait on each other. They're not in a central queue, everyone waiting for procurement, everyone waiting for any central service. Well, if you're a really small company with 50 people, that might be 10 teams of about 5 people. Then ideally you would have 10 modules, 1 for each team. An 11th module wouldn't help you. You just have a team multitasking on that module. Toyota has a lot more than 50 people. They have hundreds of thousands of people. So Toyota's next goal is to get more modules. Oh, this is a note. I was at a SAFE event this morning in the Netherlands. There were no release trains in any of the Musk companies that I ever saw. I never saw big room planning, but I also didn't see any other flavors of Agile either, for those of us who have an Agile background. I didn't see any product owners, any Scrum Masters, any stand-up meetings. I never even saw a retrospective. So what was there? Well, I'll try to show you. As I mentioned, in 2010, Tesla showed me 2 modules on what became the Model S. There was the battery pack and everything else. Those were the 2 modules. And what I recommended was try to increase the module count. And here's the current modular architecture of one of Tesla's modern products, most recent products. This is the Tesla Semi. By numbers, this is the highest capability electric truck in the world. If all of us together were on the seats mob and we're working together to try to make a better seat today, we could introduce that a little bit better seat in production today, and there would be no changes to the battery pack. The battery pack wouldn't have to change at all. And the battery pack could introduce changes today to be a little bit lighter, a little bit more efficient, have slightly more energy density, and we would not have to make any changes to the seat or to the cooling system. Now, the cooling system heats and cools the battery pack. It also heats and cools the seat. It connects to both of those things. But they can release new versions anytime, actually multiple times a day in hardware. And the reason why is, see these connections? As long as these connection points to the battery pack and the seat and the cabin, as long as they don't change, new versions can come anytime. Now, interestingly, those connection points also change. They change all the time. But when they change, there's adapters put on them. Little pieces of plastic and aluminum that adapt the electrical connections and the hot and cool fluid flow to be compatible between these changing modules. So the interfaces also change. Every day at 5 a.m., I would walk into the Tesla factory. There's no other building, there's just the factory. There's not like some lovely office where decisions are made and then outsourced engineering It's all in one building. Or in 2020, it was. It was one building, the factory. We'd all walk in at 5 a.m. and look at the board. It was just called the board. When I introduced this to other companies, I do now call it Justice Board. I did not invent this. I've made, I hope, updates. When I introduce this more broadly, I do call it the Justice Board. In Tesla, it is just called the boards. These boards show you the current bottlenecks. And when you become an employee of Tesla, you're given a set of 9 engineering rules, and you digitally sign them. You digitally sign that you will attempt to follow those engineering rules. And then you sign that you will decide what to do every day to try to have the most positive impact towards the company's mission. And then you don't have any manager. No one tells you what to do. It's actually really scary in the beginning because you walk in at 5 a.m. and you look at these boards and you decide where to go. You signed those 9 engineering rules and you were told it's up to you to figure out how to be useful. And you look at this and try to figure out the bottleneck and try to think, can I add value there today? If we zoom in on this board, here's what you see. Here is the here's the center screen in the Tesla Semi. That's the same screen in the Tesla Model 3, the small car, the small sedan, and the Tesla Model Y, the small SUV. It's the same screen, the same part, and in the Tesla Semi. What you see at 5 a.m. is the current estimated cost in pennies to make one screen. And this is a real-time number from sensors in the factory. So this isn't a human report. This is a real-time number from sensors in the factory guessing how much it costs per screen to make it right now. Then every screen is weighed by robots, every single one. And you see the real-time weight in grams of a screen. And every screen is robotically tested, every single one. And one of the numbers is how much electricity does it use, its power draw in milliwatts. And you see that real-time number. This is actual Tesla data. This has been released by Tesla. This is it. What's useful for us here in this room is most companies in hardware introduce changes every 2.5 years, 5 years, 7 years. You can actually see these numbers getting better every day. That's because we mob every day to try to make that center screen weigh a gram less today, have a milliwatt better, less power draw today, cost a penny less to make today, take a second less to manufacture today. That means our mob, our group, needs to be able to, together, design, program robots, melt plastic, pull metal from stock, talk to suppliers, but really quick ones, like suppliers that live across the street and can deliver some stuff today. And it's our job today to make it better. I'll try to explain it with a story. Here is the heat pump, the heating and cooling heart of a Tesla. Every single Tesla uses the same heat pump. It's the same part for every Tesla car. And it started with the Model S looking like this. In 2010, Tesla had a partnership with Mercedes-Benz. They were making the electric smart car for Mercedes. In exchange, Mercedes sent many engineers to Tesla, some temporarily, some joined permanently. Production engineers, part engineers, process management engineers. And the heating and cooling system of the Model S looks exactly like a Mercedes-Benz S-Class, a big luxury sedan. You have fans that are bought from suppliers, Bosch, Bose, Adaptive, Continental. You have radiators bought from suppliers, cooling lines, pumps, etc. Just like any Mercedes-Benz. Then these mobs come in production and say, what change can we make to this so it weighs a gram less today? It takes a second less to manufacture today. It costs a penny less to manufacture today. And over time, it got smaller. This is a useful piece of data. These modules actually get smaller over time. That makes more room in between them for teams to try a big experiment that might make it bigger in some dimension. Because in general, the modules get smaller. And here's what it looks like now. It's the size of 2 pairs of shoes. It takes literally seconds to make. It costs truly pennies to make. It has very few moving parts. It heats and cools the entire battery pack and all the seats, all 5 seats, and the cabin. A useful point for us is no one knew how to make this before. You couldn't have had a 5-year design cycle that would have resulted in this, or a 7-year design cycle to make this. No one knew how. The only way to discover how to make this was by these frequent small changes. Agile, right? Small frequent changes. I have a theory. We don't learn very much by talking. We get incorrect feedback from when people smile or laugh, and it doesn't mean it was correct. We don't learn much by drawing or planning. We get incorrect feedback by what looks right. The only way to learn quickly is by building. The only way to learn quickly is by building, is my current theory. That means you want to start building something new every day. You need a daily cadence to get that feedback loop. It's the only method to learn this quickly. An unfortunate example of this, there's the terrible conflict right now in Ukraine with Russia. The United States military has asked for more SpaceX antennas, and the combatants in Ukraine have asked for more SpaceX antennas. And when asked why, everyone admits there's no better antenna in the world, not any special forces, not any military, than SpaceX has. That's measured in gain. The fundamental metric of success for an antenna is its gain. And the highest gain antennas in the world are made by SpaceX. And no special forces, no military has a higher gain antenna. Wait, why is that? SpaceX doesn't even make antennas as their primary business. That's one module of a rocket. Why is it that these companies are routinely making the best breakthrough engineering ever, that humans have ever made? There's something about the way engineering is evolved in these companies that's fundamentally fast and interesting. Here's what it looks like. If at 5 a.m. we in this room decided to join the heat pump line, our first step, these are actual pictures, would be to try to make one. Not draw one, not talk about one, to try to make one physically. So we'd be mixing glue, we'd be whittling plastic with a knife, we'd be drilling metal and sweeping up the pieces of metal on the floor. That's what we'd be doing that day, starting at 5 a.m., all of us together. We'd be using methods like Mob, and we would have AI assistants. Now, while we're trying to make one heat pump that hopefully weighs a gram or more or less, for example, some of us would be reprogramming the robots to build our prototype. Well, why would we do that? We don't know if our prototype is good yet. We don't know if it's better than the previous model yet. Why would we reprogram the robots already? We only learn by building, right? So if we want to get really good at programming robots, what do we want to do every day? Program the robots. Right? So we do. We reprogram all the production robots every day. What happens is after about 100 hours of that, the people doing that usually know more about the actual limits of the production robots than the companies who sold them the robots. And when that happens, the Musk companies typically buy the robot company. That happened recently with a robotics company in Germany. The Tesla employees understood the limits of the robots better than the company making and selling them. So they just bought the company out and made it part of Tesla. Now, we do draw, but we don't draw the part. We draw and animate the manufacturing steps. This helps train the AIs to suggest better manufacturing steps. The 3D models of the manufacturing and the animations of the manufacturing are drawn, not the part, the manufacturing is drawn, so that it can be fed to the AIs to help create good training data. And the end result, the definition of done for our group, our mob, is an improved version of the heat pump is automated in production with automated test. And our goal is to get there in less than 12 hours. To go through design, build, test, and automated in production with automated test in less than 12 hours. That's our goal, and that's our goal every day. Now, there's an equal number of people working 5 p.m. to 5 a.m. Same number of people. This does something really good. In XP, extreme programming, there's this idea of group ownership. You don't own it, it's group ownership. When I worked in Tesla, I definitely couldn't feel I owned anything because every day at 5 p.m. I would hand off what I was working on to other people, and every day at 5 a.m. I would get something different again. So I couldn't feel I owned it. It was definitely group ownership. It's also really fast. Everything is 24 hours. All software, all hardware, every operation is 24 hours. And part of that is it creates this satisfaction. It's been described to me as mean time to dopamine. The satisfaction release of success. You get it every day. Some of these teams are so good, they design, analyze, build, test, deploy every 45 minutes. That's the quickest I saw, 45 minutes. I'll actually show, I have a picture of that one that was released. So what is group work, mob, with AI assistance? Here's a picture of it in the EU. This is in Giga Berlin, Giga Brandenburg. And what they do is it's 12-hour shifts, but then you have 4 days off. It's a 36-hour work week. Not bad, right? And it works in the EU. So you have a 36-hour work week. This team is going to get new parts and materials that they've never seen before multiple times a day. That's where the AI assistance helps. The AI assistance helps them make sense of these things they've not encountered before as they're trying to design, engineer, and produce on the shop floor. This is Neuralink, making medical electronics that are embedded in the human head. Approved. These are government approved now by the FDA. The approval came for human use. These mobs, if their parts touch, if the modules these teams make touch, they share an interface, they choose to work within 3 meters of each other. So they don't have to have any integration meetings at all. They just hear and can see, and they walk over, they join each other's mobs every once in a while to stay synchronized enough that they don't have integration delays. The software stacks, when I worked there in 2020, were all independent. If we were working on the seating team, we would have a seating AI that would give suggestions on how to make better seats, manufacture them lighter, cheaper, last longer, more comfortable. There's an AI theory of seat comfort that runs continuously. And it was a separate AI stack that you'd ask questions about how to make a better motor. Since I retired from Tesla in 2020, Tesla has put all of these AIs together. It's called Tesla One. And this is actually the most valuable part of the company, and I don't think most people understand that. The digital backbone of Tesla, the actual value of any Musk company, is actually its digital process to design the manufacturing system in less than 12-hour chunks. It's very well assisted. We couldn't ask Google Bard or ChatGPT to draw a more efficient electric motor than any human has ever made. They're not that good yet. But you can ask the Tesla AI that. Why? There's 5 million Teslas on the road right now, and they all send real-time data back to train Tesla's AI. Which part of the motors are hot? Which part of the motors wear out and when? How much electricity are they drawing and how much power comes out? What's their efficiency and their efficiency over time? That training data is overlapping with the CAD model of every motor Tesla has ever made. That is the data set you want for an AI that you ask, please draw me a more efficient motor than humans have ever made. And the Tesla AI can. It will draw it for you. But it won't only draw the motor for you, it will also tell you the manufacturing steps and the manufacturing tools, which is what you really want. The reason why is because every factory layout, which changes multiple times a day, its 3D model is part of the training set for Tesla's AIs. Then there are materials tests. This is a series of testing chambers. What's being measured here is different materials and how electricity flows through them and what kind of magnetic fields are generated when that happens. And how these materials age over time, and when they finally fail, how do they fail? These tests never stop running. When the parts inside fail, new materials are put in immediately. And these farms are never big enough. They are constantly expanding. This is a huge field in a desert in Texas, and it simply grows. There's no desired size other than more. The data from this is fed directly into Tesla One, which is what creates the magnetic model that you see here. Tesla's software has another very important job. This is a Model Y, the small SUV, while it's being built. And the whole car isn't assembled yet. The front with the heat pump in it has been connected, and the steering rack, the part that turns the wheels, that part's actually made by Bosch, a supplier in the EU. So the Bosch steering rack has been connected, and the Bosch steering column. And the robotic vent system. The seats aren't in yet, but the battery pack is in. The rear of the car has not yet been attached. And you might be able to read it on the screen here. It says factory mode. This is the same software stack. This is part of Tesla One. What it's doing is it's integration testing these parts as the car's assembled. Every car does this as it's assembled. It's going through the API. Can I turn the steering rack left and right? While I do it, does any part of it get hot? How hot? How much electricity does it take to turn left and right? This is likely the very first time these parts have been connected because the parts are changing every day, right? There's around 10,000 parts in a car. They're all trying to change every day. So that makes almost every car unique. What Tesla does is they keep a full CAD model of every car. There's 5 million cars, each one is 10,000 parts. That's actually not a very unreasonable number for a technology company. Every car, all parts, there's a full model because they are all potentially unique. And what Tesla One does is it puts every car in simulation through all road legal government approval tests. And each car has its own digital document, its own PDF, to request government certification for that car. Not every car needs to apply for certification. If we made a better seat and it weighed a gram less, and the reason it weighed a gram less is because we made the foam a little thinner somewhere, that doesn't need to go through a certification process again. Many changes do not require certification. Some do. And for the ones that do, that car already has its certification application ready. Most companies create a certification test every 2.5 to 7 years per car because it's expensive. Well, software, in Agile software, most of us found if we had a big, difficult testing cycle at the end, what was better is to have constant testing that never stopped. Google, Amazon, X, formerly Twitter, all run more than 1 million automated tests every second. Of course, so does Tesla. and it runs on the cars. Modules are tested individually in factory mode, then tested again as they are connected to the car. Here, the steering column, dashboard, and interior are testing each other as the car is assembled. When all teams are trying to make each part cost a penny less every day, over 4 years, the total cost of the car goes down 30%. This is actual number. Most companies are just trying to keep the cost from going up too fast. In the Musk companies, the cost actually collapses because of this group work. And since we're not just changing the parts, we're changing the production process a little bit every day, small changes frequently, agile, right? The manufacturing process gets more efficient. Here is Shanghai, and as the number of Model Ys, small SUVs, increases, the labor hours per Model Y goes down. And the same thing happens in the US. As the number of Model Ys increases, the number of cars produced increases, the labor hours to build a car goes down because we're introducing better automation and reducing part count and reducing the number of seconds to make each part a little bit every day. The goal is for 100% of staff to be engineering directly, improving the products and services. Amazingly, this process works in automotive at Tesla, pure software at X, construction at the Boring Company, medical devices at Neuralink, and aerospace at SpaceX. SpaceX made 1,000 hardware changes to the world's largest rocket in 69 days. A lot of companies in software would be thrilled to make 1,000 changes in software in 69 days. And SpaceX did it in hardware and on the largest rocket ever. Mark Zuckerberg credits Elon Musk with kicking off the tech trend of firing middle managers when other CEOs were a little shy. Now, that's not entirely accurate. It's never happened that a media company has written a misleading headline to get reads or clicks, right? That's never happened, right? Musk never hired middle managers. Musk never had them. So there weren't any middle managers to fire. This was actually sent to me by Marit Lanti, who wrote the documents that became SAFe, became Scaled Agile. And she tagged me and said, Musk is replacing middle management with AI. Thank you so much, Marit. Ted Malaska, Senior Director of Application Software at SpaceX, posted on LinkedIn, "We are looking for outstanding engineers to work in a game-changing environment. No program managers, project managers, or product managers. No product owners either. No agile. No architects. No designer. And we're in the office every day. But you get to change the world and work on rockets." How could you possibly make a rocket that humans ride on, that docks with the International Space Station, and brings live humans back to Earth without any architects, without any designers, without any project management? How could you do that? You split the rockets into modules that can be built and tested in any order, and you run mobs assisted by AI at the same time on every module. And I think without good digital assistance, it would take longer than 12 hours. But I think you could do this even with just ChatGPT and Google Bard. You just might need a 1-month iteration for each hardware module, maybe. But if you train your own AI stack, you can, and you have your own robotic assistants, you can compress the time faster than that. The Musk companies each have a justice board. They just call it the boards. And all of them at the top have a 1,000-year goal. For Tesla, it's accelerate the transition to sustainable energy. For SpaceX, it's colonize other planets. They write it even more beautifully than that. Spread the light of consciousness out among the stars. Ted Malaska writes, honestly, we don't think of the competition much here at SpaceX. It's more about the impossible goal of Mars that drives us. And that really resonates with my experience in Tesla. It really felt, for me, my experience in the company was that it was about trying to save the environment. Whether you believe in that or not, I do, and it resonated with me. I actually felt like I was doing something helping save the world. I really did, every day. So it worked for me anyway. Now, I don't know if Elon Musk is a genius, but what I do think Elon is great at doing is choosing the bottlenecking KPI towards that goal. So Elon chooses these. If you're going to try to colonize Mars and other planets, you might think SpaceX should build farming technology that works on Mars. That SpaceX should build water reuse technologies, better air reuse technologies, but they don't. Elon says, it costs so much to put a kilogram on Mars right now that even if we made great farming technology, we couldn't afford to put it there. First, we need to make it cheap to put stuff on Mars. Then worry about what stuff we put on Mars. And I think Elon's completely right. I think this is Elon's gift. And in fact, it's even too big to say, make it cheap to put a kilogram on Mars. First, make it cheap to put a kilogram into orbit around Earth. So that's the, what's that one? Does that mean I'm over time, or that means there's 10 minutes?
10 minutes.
Okay. Okay. So every 3 meters in every SpaceX facility, there's a monitor showing in real time the current cost to put a kilogram into low Earth orbit. On every SpaceX employee's phone, you can see the current cost per kilogram into low Earth orbit. This intense focus on one KPI has made it so SpaceX has the lowest cost per kilogram into low Earth orbit. It's so cheap for SpaceX to put something into orbit that SpaceX has won 2/3 of the world's commercial satellite launches. 2/3 of them are SpaceX. They're the most profitable aerospace company ever. They are the fastest growing aerospace company ever. And their engineering is so good that the next lowest cost into orbit is the previous version of SpaceX rocket. Third place is the version before that. And fourth place is all of China. So you have one company that is 3 versions ahead of the next player, and the next player isn't another company, it's an entire country. This is a bizarre phenomenon of engineering. So when you walk into SpaceX every day, you propose through an app on your phone a child KPI that could possibly be improved today. For example, do you think maybe you could get one part of the rocket to take a second or less to build today? One part. Could you reduce 1 gram out of one part of the rocket somewhere today? Could you reduce a penny of one part of a rocket? Or could you add 1 gram more thrust today? And to make this work, that means you have to start building a new rocket every day. And this is the actual downside of Agile hardware. The actual difficult part is that means you have a huge fleet of hardware because you're making a new rocket every day. There are so many rockets that SpaceX cannot use them all. They have the largest rocket fleet in the world and ever. So what SpaceX does is they prioritize destructive tests as frequently as they're allowed to by the FAA. by the government authority for launching rockets. They intentionally try to blow these things up so they can recycle the pieces as fast as they can. And it's not that the previous versions aren't good, but when you're improving this fast, something you made even 1 month ago is embarrassing compared to what you can make now. You have so many better systems. And this results in the business model. Most companies do this the other way around. They start with a business model and then figure out their processes and then ultimately their values. The Musk companies start with their value, their mission, and then this stack up of KPIs creates their business model. When I worked with the United Launch Alliance, when I worked with Ariane Group, Airbus Military, they get a contract to put a satellite into orbit and they build a rocket for that launch. So it's a waterfall. They design, build, test, deploy one rocket for that launch. And that means the pace of learning is much slower. They build one rocket. They don't start building a new rocket every day. SpaceX prioritizes building a better rocket every day, and they don't know which rocket you're going to launch on. So you don't buy a rocket, you buy a ride. The business model has resulted from this stack up of KPIs. It's like ordering an Uber. You don't know which car is going to come, but you ask for a car to come at this time, at this place, and then a car comes. Well, SpaceX decides which rocket you're going to ride on based on which rocket meets the definition of ready on your launch date. So you pick a launch window and kilograms in orbit, and SpaceX assigns you a rocket just in time. The core foundation of this seems to be a self-organized group of people doing the design, the build, the test, and deploy assisted by AI. I'll call that Mob AI. For any comments or questions or corrections that we don't have time for now, I love social media, so please connect with me there and say, Joe, you were wrong about this, or Joe, this helped me, or you can ask questions. That's totally fine and anytime, and I hope we can have some of that conversation now. I'm Joe Justice. Thank you for hanging out with me today.